In the heart of a mountain, giant drills are breaking apart rock masses, revealing tons of crystalline salt with a dazzling pink glow. Here is one of the most impressive underground treasures in the world, the Himalayan pink salt mine. These giant machines, operating in the Kura salt mine in Pakistan, are constantly digging up thousands of tons of salt daily. In tunnels extending hundreds of meters below the surface, high-powered crushers break up the salt veins and transport them to the surface on special conveyor belts. Then, large rock blocks are turned into millimeter crystals with giant conveyor systems and hammer mills. The actual process in blue sapphire mining begins after the extraction of the mineral soil. This extracted mixture is first washed with high-pressure water, and then large pieces are separated with the help of vibrating screens. After this stage, the material is taken to special washing tanks that separate the sapphires using density differences. Here, the heavy sapphire stones sink to the bottom, while the light waste is removed from the surface. The stones obtained are manually checked and sorted by expert workers, and only those with a certain size and color pass to the next stage. Finally, these raw sapphires are shaped in precision cutting machines and made ready for use by adding shine. The salt mining process begins with special drilling machines to reach the huge salt deposits beneath the surface. Salt blocks extracted by blasting or mechanical excavation methods are collected from underground galleries by giant loaders and transported to the surface by conveyor systems. The salt that reaches the surface is crushed and ground in crushing machines, and then passed through screening systems to be separated according to grain size. In the final stage, the dried and purified salt is processed in packaging lines to reach the table. Aluminum mining begins with the extraction of the ore called bauxite from layers close to the surface, and the open pit mining method is usually used. Large excavators and loaders scrape off the bauxite layers and load them onto trucks, and this raw material is sent to refineries for processing. In the refinery stage, bauxite is crushed and processed with caustic soda at high temperatures to form a white powder called alumina. The alumina obtained is converted into pure aluminum by electrolysis, making it ready for industrial use. Phosphate mining is usually done by open pit method, and first the upper layers of the soil are scraped with large dozers to reach the phosphate-bearing layers. Then excavators dig these phosphate rocks, load them onto huge trucks, and carry them to crushing and screening plants for processing. Here the rocks are first broken down with crushers, then ground into fine pieces and separated from clay and other impurities in the washing unit. The pure phosphate obtained is sent to refineries to be used in the production of fertilizers and various chemical products. Zeolite mining begins with the identification of zeolite deposits near the surface using geological maps, and then excavating the soil using the open pit method. Large shovels and loaders extract zeolite-bearing rocks and load them onto trucks, which transport the raw material to crushing plants. Zeolite, which is broken into smaller pieces by crushing and grinding processes, is passed through screening systems and classified according to different grain sizes. Finally, the zeolite mineral, which is dehumidified in drying units, is packaged for various industrial and agricultural uses. Graphite mining is usually carried out by open pit or underground mining methods, and the process begins with the removal of graphite-containing rocks with large excavators. These rocks are ground into smaller pieces in crushing machines, and then subjected to a special separation process called flotation. In the flotation process, graphite particles are brought to the surface with water and chemical additives, while other minerals are precipitated and separated. The resulting graphite concentrate is prepared for use in high-tech areas such as batteries, steel, and lubricants after drying and purification processes. Kaolin mining begins with the identification of deposits containing white clay and is usually carried out by open-pit methods. Large excavators and dozers carefully dig into the soft formations containing kaolin below the surface and load them onto trucks. This raw kaolin is transported to processing plants where it is mixed with water to form a slurry, then separated from sand, iron, and other impurities using hydrocyclones and centrifuges. The purified kaolin is packaged as a fine white powder for use in the ceramics, paper, and cosmetics industries after passing through drying systems. Limestone mining is usually carried out by open pit method, and the process starts with stripping the surface vegetation and soil layer. Then, explosives are placed in the rocks with drilling machines, and large limestone blocks are removed with controlled blasting. These blocks are transported to stone crushing plants with the help of excavators and huge trucks, where they are broken into smaller pieces using crushers. The ground limestone is classified and made ready for shipment for use in cement production, road construction, or construction industry. The diamond mining process is shaped by determining the area where the ore is located through geological analysis, and usually starting with open pit or underground mining methods. Kimberlite tubes carrying diamonds close to the surface are dug with large excavators, and the extracted rocks are transported to crushing plants. These rocks are broken into pieces in powerful crushing machines, and then separated by the density difference method. Diamonds are collected by sinking to the bottom in special separator systems because they are denser than other stones. In the final stage, these raw diamonds are selected by hand, classified, and sent to jewelry processing centers for the cutting process.